So the last thing we're going to talk about on this notes page is the remainder theorem. It's basically another shortcut for you to automatically determine, I shouldn't say automatically because it's still a little bit of a process, but it's just a third way of determining whether or what the remainder of a function is when you would be dividing, okay? And knowing what the remainder is allows you to determine whether the given factor is either a true factor or not a factor, okay? So I'm going to give you it, and then we'll talk about what it means, and then I'm going to prove it to you, because you should know that the word theorem is probably familiar to you if you've taken geometry. You should know that theorem means it's a theory, so you got to be able to prove it. So I'm going to prove it to you after we've tried it, okay? So the remainder theorem says this: to find the remainder of a function, we simply need to evaluate the function for the given factor. So what does evaluate mean? Well, we've done this already in Algebra 2 this year, and we did it a little bit in Algebra 1. We talked about what's called function notation. This is function notation. It really is read as f of x. And so anytime that you write f of x and you write something like this, you're basically saying that the value of this function, because this also equals y, okay? The value of the function is going to change based upon what you decide to plug in for x. If you plug in 2 for the x's, you're going to get a different value for this when you add it all up than you would if you plugged in a 3. So when we were doing functions in the past, you would sometimes be asked to plug in something to the function. So if it said f of 3, it means evaluate the function given that x equals 3. So you would go and you would plug in 3 every time you saw an x, and then you would solve it. Okay? That's the same idea here. The only difference is they're not using an f, they're using a p, since we're dealing with polynomials, okay? So that's really the only difference. So it says find p of -1 for this polynomial. P of x equals 2x to the 4th plus 6x cubed minus 5x squared minus 60. So what they're telling you is find out what would happen in this polynomial if I plugged in a -1 for all the x's. Okay, so that's what we're going to do. We're going to write them out, and every time we see an x, we're going to put in a -1. Okay, that's what we're going to do. So remember, you can use a calculator for this too, but remember when you use a calculator, and it's later in this chapter, you're going to have to use a calculator because we're going to get some very large numbers. So remember that if you use a calculator, you need to remember to put in these parentheses. Otherwise, if you put 2 minus 1 cubed, it's not going to know what you're referring to. The thing that's, I'm sorry, to the 4th power. The thing that's being raised to the 4th power is -1, so you need to put parentheses so the calculator knows it's only applying to the -1, okay? But this is easy because it's -1, so we can do this really easily because multiplying with 1s are always going to give us 1s. Now the difference is, because it's a -1, we do have to pay attention to the exponents. You should know that if you have a pair, any pairs of -1s would cancel out, right? So if you have a pair, and a pair, that would equal all positive. That would multiply out to all +1, okay? So if you have an even exponent, all of the negatives are going to cancel. But if you have an odd exponent, they're not. So -1 to the 4th power, those would all cancel out, so it would just be a +1. But when you do -1 cubed, it's -1 times -1 times -1. You only have one pair that cancels, and you've got a remaining negative, okay? So that's going to give me a negative answer, okay? So this one's going to be plus 6 times -1. Then I have -5, and then I have to square this. -1 squared is going to make them cancel. It'll be a +1. And then I got the -60, which doesn't have an x. So at this point, all I have to do is I have to evaluate what those values are and do the math. Okay, so I'm going to do that. 2 times 1 is 2. +6 times -1 is -6. -5 times 1 is -5, and then I have a -60. So if I do the math, I subtract 2 minus 6, that's -4. -4 minus 5 is -9. -9 minus 60 is -69. This is the remainder, which means that technically then -1 is not a factor. Okay? So how do I know this is true? Okay? How can I be sure that all I got to do to determine the remainder of a function is to plug in the value of the factor, and then it will spit out for me at the end the remainder? Okay? Well, let's do synthetic division with this factor. The factor is -1. Now, let's go back to our coefficients. Remember, the coefficients are going to be detached from the variables. The only thing you got to be careful of is it looks like we're missing a term right here. We're missing an x term. So when we get to that place, we're going to have to put in a 0. Okay? So I have 2, 6, -5, 0, because I got to leave a placeholder, and then -60. And now I'm going to do synthetic division and see if I get a remainder when I get to this last column, if it's the same thing as -69. So remember, I'm going to add down. 2 plus 0 is 2. Then I multiply back up. 2 times -1 is -2. Add down. 6 plus -2 is going to give me 4. Multiply up. -1 times 4 is -4. Add down. -5 plus -4 is -9. Multiply up. -9 times -1 is +9. So 0 plus 9 is 9. And then right here in the last column, watch what happens when I multiply up. 9 plus -1 is -9. What do you get when you add -60 plus -69? You get -69. That's the same remainder. Okay? So it's just another shortcut. I don't know how much you'll consider it a shortcut. If you can use a calculator, but there's still, in my opinion, several steps. But it works both ways. So if we're trying to quickly and easily find a factor, it actually might take us a little longer to set up a bunch and take up more paper space to do a synthetic division problem. It would be much faster to just use a calculator and try to find a true factor that doesn't have a remainder. Because if we can find one that doesn't have a remainder, that gets us started on the factoring process. So this is going to be very useful and is going to come in handy again when we start factoring more next week. Okay, so that's it for the synthetic division and long division, which is going to be kind of the beginnings of factoring for us. And so now we're going to look at another factoring method, and this one is very similar to what we do with difference of two squares with quadratic equations, but they're called sum of cubes and difference of cubes. And these are just patterns that we have to memorize. That's all we can do is just memorize the patterns. So that's going to be the first factoring method that we're going to learn using new methods that we haven't been taught before.